Hello, and welcome to this fourth in a series of tutorials intended for citizen scientist amateurs that show how to use satellite images to monitor changes in vegetation extent and condition. In this tutorial, we will calculate 3 vegetation indices using Landsat satellite imagery prepared in previous tutorials. Before we get started, here are the other tutorials in this series. Check the description below for links to these tutorials. These are the images downloaded and prepared in a preceding tutorial, which you stored in appropriately named folders on your computer. These are the 3 indices that we will be calculating in this tutorial using these 6 corrected spectral band images. Each index has particular uses and benefits which can aid in monitoring vegetation extent and condition. Here are the formulas used to calculate the indices. The bands shown are Landsat image bands. The indices are all normalized, meaning that when using these scaled and corrected images of a previous tutorial, all produce numerical values between -1 and 1, with higher values indicating healthier vegetation. This tutorial will focus on a region of protected lands in northern Door County, Wisconsin, USA, but you can use any region of interest for this tutorial and the remaining tutorials in this series. The region of interest covered here includes over 4,700 acres of protected lands grouped into 3 areas. The unique features of this region provide impetus for monitoring changes in region vegetation, extent, and condition. For this tutorial, you will start by creating a QGIS project where we will be calculating the indices. For this new project, we create 2 QGIS groups for the raster layers we will be generating here, plus a group to hold the corrected images that we prepared in a previous tutorial. Next, we create a shapefile mask layer that covers a region of interest. As mentioned, this region includes the Bridges Sanctuary, Toft Point, and Mud Lake areas. But of course, you can choose a different region of interest. This tutorial series works regardless of the specified region of interest. Now we'll load the images that we need to calculate the vegetation indices. Load the corrected images raster layers from a previous tutorial into the associated QGIS group. Note that here we really only need bands 3, 4, 5, and 6, but we'll take all of the bands along for the ride in case there are other indices we wish to calculate. Next, we'll clip the corrected images so that they cover only our region of interest. Clipping is done with the raster extraction tool. Clip the raster layers one at a time using the region mask shapefile layer that you just created. Make sure to select these options. Here then are our 6 clipped raster layers which cover just our region of interest. We can now calculate our 3 vegetation indices. We do this using the raster calculator as demonstrated here for the NDVI index. And here is NDVI for August 15th, 2023. As expected, NDVI ranges from -1 to 1, with most of the image pixels being greater than 0, since this is an image taken at the height of summer. Here is GNDVI with a somewhat lower maximum value, but overall similar appearance. And here is NDMI with the maximum range of values, but apparently lower median values as seen from the somewhat darker image. Here then are false color images of the 3 indices for August 15th, 2023, And for comparison, here are false color images of the 3 indices from March 3rd, 2024. Looking at the example of NDVI, these images are certainly saying something about what's going on with vegetation over the course of a year. But how can such imagery be used to quantitatively assess vegetation extent and condition? The task of quantitative assessment is complicated when there is a need to differentiate between different types of vegetation. For example, let's say you were interested in changes in deciduous forests versus coniferous forests. The question here is, how can you differentiate among vegetation types as they appear on the satellite imagery? The next tutorial in this series addresses the question of how to use satellite images to monitor extent and condition of different vegetation types. So that's it for this tutorial. Hope you will enjoy the next tutorial in this series. Please note that this series of tutorials would not have been possible without the generous assistance of staff at the USGS Earth Resources Observation and Science Center. If you have questions on how to use Landsat data, contact their customer service. All Landsat data used here courtesy of the U.S. Geological Survey. Thanks for watching this video. See the description below for links to all of the tutorials in this series.